Hello and welcome. Today's topic is Venn diagrams and algebra of sets. Definition: a Venn diagram is a diagram that shows the relationship between and among a finite collection of sets. If we have two or more sets, we can use a Venn diagram to show the logical relationship among these sets as well as the cardinality of those sets. This is an example of Venn diagram. We have three circles here and they are the sets. Symbols used in Venn diagrams. Circle. A circle represents a set and a rectangle represents universal set. If you want to know what are these, then refer my previous videos. Some important Venn diagrams. This is a Venn diagram of complement of a set. A set A has a complement A dash. The red portion that you are seeing here is its complement. This is a Venn diagram of difference operation. Set difference. Here we have only the portion of A but not of B. This shows A minus B. This Venn diagram that you see now is an example of union. We have both A and B and also their common elements. The example that you are seeing now is of intersection. We have only the common elements of A and B. Let us look at some properties. First of all, properties of union and then intersection. In properties of union, we have four properties, namely commutative, associative, identity, and distributive. Commutative means that if we change the order of the sets, the operation of union gives us same result in both the case. In associative, if we have three sets and then we do their union, in both the ways we will get same answer. Identity means that if we have union of set with empty set, then we will get that set itself. And in distributive, A union B intersection C gives A union B intersection A union C. Distributive property is the most important property. Same properties are there for intersection as well. Now let us look at the properties of complement and difference. In complement, we have four properties, namely union, intersection, double complement, empty, and universal set. First property says that if A union A complement is done, we will get the full universal set back. If intersection is done, they have no element in common. That's why we get an empty set. Double complement says that if we do a complement of a already complemented set, then we get the set itself. Empty and universal set says that complement of empty set gives universal set. Now, properties of difference. Same set. That is, if we subtract same set or if we do a difference of same sets, we will get a null set. And if we subtract a set by empty set, we will get that set itself. Important formulae: N of A union B, that is cardinality of A union B, or number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. If there is nothing common in A and B, that is A intersection B is equal to phi, that is they are disjoint sets, then n of A union B is equal to n of A plus n of B. These four properties are very important and are used in numerical problems. Practice time. Shade that region that represents A complement intersection B complement. This means we have to shade the region where there are no elements of A and no elements of B. Second, A intersection B complement. There must be elements of A but no element of B. This gives output same as the difference operator. Now A complement intersection B, there must be elements of B but not A. This gives output as B minus A. Thank you. The date of our quiz competition is announced as 1st of July 2020. There is no age limit. Amazing prizes. Registration form will be available soon. For any queries, contact on anandtutorials20@gmail.com. Also, visit the blogs link in our description. Like, share and subscribe to this YouTube channel. Like and follow Anand Tutorials on Facebook and Instagram. Link in description.